All right, so we are getting close to the end of our unit on trig, and what we're going to focus on over the next couple lessons, all right, is solving for angles and sides in non-right triangles. All right, so we learned Pythagorean theorem to help solve for sides in a right triangle. We've learned sine, cosine, and tangent, all right, to solve for angles and sides in right triangles. Now what we're going to do is move into, well, what if I don't have a right triangle? How do I find missing angles and missing sides? And we're going to talk about two things. In our first lesson today, all right, which is Unit 8, Lesson 8, on page 110, we're going to talk about the law of sines. And we're going to develop the law of sines, all right, from what we know about area of a triangle. I'm going to get in that in just a minute. And then in our next lesson, we're going to talk about, all right, law of cosines. All right, so you can see standard 20.1 and 20.3, I can find side lengths and angle values of non-right triangles using the law of sines and solve application problems. So just like we did with right triangles, once we kind of get the general sense of law of sines, we want to then be able to take that into, all right, kind of some real world application type situation, all right, and transfer your knowledge to do that. Now, what I'm going to do is skip the opener for now, and I'm going to develop the law of sines for you. So if you want to just watch, you can. All right, that'd be great. You don't necessarily have to take notes on this. And what the law of sines is developed from, all right, is the idea of area. And when we think about area, the area formula for a triangle is 1/2 base times height. Now here's the interesting part, right? A triangle can have 3 sets of heights and bases depending on the orientation, all right, that we look at a triangle. So for example, I have triangle ABC here, and I could drop in height or an altitude from angle B to this side AC. All right, and so that is one way of creating a height in that triangle to find the area. Now if I look, the base of this triangle is little b here. So I'm going to put that in right here, little b. But notice, I don't know what the height is, and I want to get it in terms of the things I know about this triangle, the sides and angles. So here's what we do. We're going to now connect this to, all right, what we know about right triangles. And I'm going to find, all right, the value of h here in terms of sine of a here. So that, once again, this is a right triangle. So if I look here, I could write this as sine of a equals, and then the opposite side is h, and then in this right triangle here on the left side, the hypotenuse would be c. So that would be h over c. And then notice if I cross multiply here, I get c times the sine of a is equal to the height. And I'm just going to take all of this and substitute for h here. So c sine of a. And that's how I could find the area of this triangle, all in terms of the triangle. So I don't actually have to know the exact height here. So notice I would have to know BC and angle A. So not only is this going to develop the law of sines, it shows how we can kind of create an algorithm, all right, to find the height of a triangle or the area of a triangle without actually knowing that, all right? Now, notice, I'm going to go to my second triangle here. But notice I could also drop an altitude from, all right, or a height from angle A. And notice once I do that, now a, little a here becomes the base. So that's our b right there. So this is 1/2 a. Now notice the height this time, all right, I'm going to now solve for and get this in terms of c here. So notice if I look at this little triangle right here, all right, I could say sine of c is equal to the opposite side, which would be h. And notice now b is the hypotenuse in this triangle like this. And just like what we did above, all right, I could cross multiply and I get b sine of c is equal to h. And once again, I can drop that in for the height of my triangle. So b sine of c, like that. But notice there's a third angle, right, in the triangle. I could also drop, if I wanted to, an altitude or a height from angle c here. All right, and this is what I mean by creating those 3 possibilities, right? It depends on what angle we're looking from. And notice in this situation, right, c would be my base, all right? And so I would have 1/2 c. And then now this time, I'm going to get the height in terms of my angle b here. So I could say sine of b equals to h, which is the opposite side. And then in this triangle now, little a is the hypotenuse. And once again, I could cross multiply, and I get a sine of b is equal to h. And I, once again, can drop that in here. And so what happens here, and I've had to scroll through this, is we get 3 different area formulas for this triangle depending on, all right, which angle, all right, we drop the height from. Now, it doesn't matter, right, because the area of the triangle is going to be the area of the triangle. So it doesn't matter if I'm looking at the first, second, or the third, all right, viewpoint, right? It doesn't matter which height I drop, all right, because the area is going to be the same. which means all three of these area formulas, all right, are the same. So that allows me to set them equal. So I'm going to do that right here. So my first one was 1/2 BC sine of A equals my second one, which is 1/2 AB sine of C, which is equal to the third one, and I'm just going to rewrite this as A times C, just to put it in alphabetical order, sine of B. All three of those areas would have to be equal. All right, now what I'm going to do is just a little bit of algebraic manipulation to develop the law of sines. So the first thing is, notice we have 1/2 in all three pieces. So what I'm going to do is just use one of our properties of equality and multiply that entire equation by 2. All right, and notice if I do that, that leaves me BC sine of A equals AB sine of C, which is equal to AC sine of B. And then now, once again, I'm going to use another property of equality, which says I can divide my equation by anything I want, as long as I divide all the pieces by that same thing. And what I'm going to divide everything by is A times B times C, little a times little b times little c. And watch what happens. So I'm going to do that to all three pieces here. And notice what happens here. B divided by B is 1, C divided by C is 1, and that leaves me the sine of A over little a. B divided by B is 1, A divided by A is 1, and that leaves me sine of C over C. A divided by A is 1, C divided by C is 1, and that leaves me sine of B over B. And this is our law of sines. And what this says is that I can create a ratio of the sine of an angle on its opposite side and set that equal to another ratio of the sine of that angle and the side opposite of that angle. So these are all big letters and these are all little letters. And remember, big letters, capital letters represent the angles, and little letters, all right, represent the side lengths. All right, so that is our law of sines. So let's go back to our note sheet here. All right, and so here's our law of sines. All right, so sine of A over A, and I'm just going to put it in alphabetical order, sine of B over B, and sine of C over C. Now, notice this has the angles, sine of the angles in the top in the numerators, and the side lengths in the denominator. But remember, one of our properties of proportion says we could flip that if we want. So you might also see this as A, sine of A, B, sine of B, and C, sine of C, like that. And so once again, it doesn't matter, right? The ratio is the same, right? It's the sine of A, sine of the angle to its opposite side. All right, and so it doesn't matter if we do the angle to side or side to angle, as long as we're consistent throughout the entire proportion. All right. Now, so what this means, all right, why this work we just developed. And here's what this means, is that I can solve, and notice here are the three angles in the triangle, here are the three sides in the triangle. As long as I have 3 out of 4 pieces, I can solve for the other missing piece. All right, and I can set any pair, all right, equal to each other to create a proportion. All right, so we have all 3 equal to us, but that means I could do these 2 together, I could do these 2 together, I could do these 2 together. All right, so which, depending on what information I have, and we'll see that as we work through some examples. Now, here's the other piece, is that I have to have one complete ratio in order to use all sines. So that means I have to have one angle and the side opposite of it. And so what I'm going to say here is that when you think about your information, what this means is we have to either have angle, side, angle information, all right, or angle, angle, side information. All right, now we're not, and I'm not saying this I'm saying it in the same sense of congruency, but we're not trying to prove congruency, but as far as like the type of information you have. So let me look at a couple triangles here. And so what I mean by that is if we think about angle, or an ABC here. So when I say angle, side, angle, so let's say we know angle, so let's say this is 50, we say this is 17, and we know that this is 28 degrees. So there's angle, side, angle. Well, notice I have this angle, but I don't have that side, so that's not one complete ratio. I have this angle, but I don't have this side, so that's not one complete ratio. But if I know these 2 angles, I can find angle C. All right, and so this is 50, that's 78. All right, so that means this is 102, even though it doesn't look like a 102 degree angle, it's 102. And so notice, now that gives me one complete ratio. All right, so I'm like, oh, I get sine of 102 over 17. And then that equals 2. And then notice, now I can set up a ratio with any of these other angles, right? So I can say, oh, this is sine of 50, and I want to find little a. And I could do that, and now I have a proportion I can solve. Or I can say sine of 102 over 17 equals sine of 28, and I can maybe look for little b. So now, by having that angle side angle information, it allows me to create one complete ratio, one angle, all right, with its side opposite. All right. I also said we could use angle, angle, side, right? So let's just change this a little bit. Let's say this is 50, this was 28, and this was the 17. All right. So now, once again, notice angle, angle, side. Now that naturally gives us our ratio. So I know, oh, there's sine of 50 over 17. So I have one complete ratio from angle, angle, side information within my problem. And notice I can find this angle the same way, because anytime we know two angles, we can always find the third angle. All right. And then once again, all right, now I can set up my proportions, right? Like, oh, I want to find little c. So that would be sine of 102 over c. All right. And then I can say, oh, I have sine of 50 over 17 equals, and then I could find little b, because that would be sine of 28 over little b. All right, so that is how law of sines works. But to do that, like I said, you have to have one complete ratio. So we have to know one angle and the side opposite, all right, in order to solve. All right, there you go. All right, and then notice I did everything with the angles on top. That's just what I typically do. It does not matter. And then once again, final point of emphasis here, all right, before we get to a couple of examples, notice that everything's in proportion. So that means we cross multiply to solve. All right, so let's go to an example here. All right, so find BC. All right, so BC here, that's little a, because that's opposite A. We know A is 33 degrees. We know B is 105 degrees. And we know little b, all right, little b is 37.9. So there it is right there. So once again, notice we have angle, angle, side information. And so I always want to set up that ratio I know. So I know my angle and I know this side. So sine of 105 over 37.9 is going to equal to sine of 33 over A. All right, so let me grab my calculator. All right, so I had to grab my calculator real quick. Now, once again, remember sine of 105, sine of 33 are numbers. So I'm going to leave them as that. I'm not going to find their decimals and round or anything right now until the very end. But I'm going to cross multiply, and I'm going to do that right here. I'm just going to bring that up right here. So when I cross multiply here, I get A times the sine of 105 equals, and then when I cross multiply here, I get 37.9 times the sine of 33. And then just like I would anytime, right, if I have a number times A, right, so if I had 6A equals 18, I would divide by 6 on both sides, right, to get my value. All right, so remember, sine of 105 is just some number. It may not be an integer number like 6, but it's a number. So I'm going to divide by that number, sine of 105. I'm going to divide this side by sine of 105. And the reason I'm doing that, once again, is just to be more accurate with my answer at the end. So now when I go to my calculator, right, I can do 37.9 times sine of 33. And then once again, just make sure your calculator's in degree mode since we're working with degrees. Hit enter. And then I can divide that by sine of 105. All right, so there's 21.36, all right? And so I'm going to say this is 21.4. Oh, nope, we're solving for a size, so 21.4 units, whatever we are solving for. All right, so there's how we do that. And if we wanted to find angle C, right, or excuse me, side little c here, we could just repeat the process because I know these two angles, right? So I can just go, oh, 180 minus 33 minus 105, so angle C has to be 42. And then I can set up my, all right, law of sines again. And then once again, keep using the known ratio. All right, so once again, we always want to use the given information as much as possible because if I made a small mistake over here, all right, I don't want to compound that by using that again. All right, so always go back to the clean information you know from the beginning. All right, let's take a look at another problem here. So let's flip to page 111 here. All right, so let's look at, all right, I'm going to try to find an example here. Let's go over to number 5 here, there, because I want to set up one, all right, where we have to find an angle so you can see how to do that. All right, so now, once again, I'm always a big believer in, all right, making a diagram, all right, and drawing and filling in information to help you. So let's do that. So let's do triangle RST. So here's R, here's S, here's T. RT is 11, ST is 18, and R is 120. Okay, So you can see right now, here's our complete ratio. And we want to know what the measure of angle S is. All right, so we're looking for angle S right here. So my known ratio would be sine of 120 over 18 equals, and I'm looking for the sine of angle S, and that's over 11. Now, once again, the wonderful thing about this is, once we set it up, we solve the same way. So it's a proportion. We're going to cross multiply. So now, I'm going to just jump here to 11 times sine of 120 equals sine of S. And notice I don't have to cross multiply this way because I'm solving for this guy. All right, so I'm solving for sine. So I'm going to leave that 18 in the denominator. I'm just going to cross multiply right here and leave that 18 in the denominator. Now remember, anytime we're solving for an angle, we have to use the inverse trig function. So here's sine inverse. And then once again, I'm just going to put all of this into my calculator, all right, to make it as accurate as possible. So, all right, so second sine inverse. And then I'm just going to put in parentheses here 11 times sine of 120 divided, and then I'm going to close parentheses, divided by 18. All right, and there's my answer for my angle. So I know angle S is basically 32 degrees. All right, so 32 degrees is equal to angle S. All right, so there's 32 degrees. And then once again, once I know these two, now in this case, I have to use my information that I solved for, because if I wanted to find angle T, all right, in order to find little t here, or RS, I would have to use that information. So sometimes you have to use the information you solve for, but if you don't have to, don't. All right, my friends, there is the law of sines for you. Go ahead and finish this lesson up, and we'll finish our trig unit with the law of cosines next time.